Let us now solve question 4. Question 4. Yeah, we're to balance this equation, this chemical equation. Let's bring out the equation properly so that we can balance it. Now, to balance this chemical equation, let us list out the number of atoms for each element. Now, here we have one atom. Here we have one Na. Over here we have one oxygen atom, one hydrogen atom, H2. These two hydrogen atoms, one oxygen atom, Na, one sodium atom, one hydrogen atom, P3, that is 3 phosphorus atoms, 2 oxygen atoms, P phosphorus, that is 1 phosphorus atom, then H3, 3 hydrogen atoms. Now let's assume the coefficient balancing them are A in front of this, B in front of this, C in front of this, D in front of this, and then E in front of this. Okay, let's now multiply all these numbers by their coefficients. 1A, this is A, 1 times B, that is B. For the oxygen, 1 times B, that's also B. 1 times B, that's also B. Then 2 times C, this is 2C. 1 times C, that is C. 1 times D, that is D. 1 times D, that's also D. 3 times D, that is 3D. 2 times D, that is 2D. 1 times E, that's E. 3 times E, that is 3E. Okay, now that we've gotten the actual number of atoms present on both sides, we go ahead to balance the equation. Let's start from element P. Phosphorus. For this phosphorus, how many atoms of phosphorus are here? That's A. There is no atom of phosphorus on the reactant side anymore. So move on to the product side. On the product side, phosphorus 3D. So the number of phosphorus atoms on the product side is 3D. So I put 3D there. 3D. Okay. Then there's also phosphorus on this side. So still on the product side. So I would say plus. How many phosphorus here? E. Okay, I'm done with phosphorus. Let me move on to sodium. Sodium now. Sodium, that's Na. How many sodium atoms are here? B. No sodium atom on the reactant side again, so is equal to, let's go to the product side. For the product side, we have it here, it's equal to D. Alright, then move on to oxygen. For oxygen, how many oxygen atoms are here? B. On the reactant side, still on the reactant side, we have another one, C. That's C, B plus C. There's no oxygen atom on the reactant side again, so I move on to the product side now. For the product side, oxygen, this is 2D. Then there's no oxygen again. That's all about oxygen. I think we have exhausted all the elements present. Okay, hydrogen now. Sorry, we have hydrogen left. How many hydrogen atoms are here? That's B. Still on the reactant side, we have 2C of hydrogen here. 2C. Okay, let's go to the other side for the hydrogen. This is D. Plus, what about air? How many hydrogen atoms are here? That's 3E. 3E. Alright, so we are set to solve the problem. So we start the solution by saying which one has the highest coefficient here. Looking through, I think the one that has the highest coefficient is D. D. So let's pick D. Let D be 1. Let D be equal to 1. Now, from that simple equation, look at sodium. For sodium, if D is equal to 1, look at this, B is equal to D. Since B is equal to D, that means B is equal to D, implies, let me read this now, B is also going to be 1, because D is 1. So this one, this is going to be 1. Okay, this one is an assumption which might change later, and of course when it changes, other values will change correspondingly. Now b is equal to the b is 1. Now move ahead to let's see the phosphorus, this equation here. This is a is equal to 3d. 3d is 3 into 1 because our d has been assumed to be 1, plus e. That of course means a is equal to 3 plus e. Let's keep that for a while. We're coming back there. Then for this one, our b is 1. B here is 1 plus c. We have not yet gotten c, so I put c is equal to 2d. D is 1 also, so I write 2 into 1, 2 bracket 1, 2 times 1. So this becomes how do I put it now? Let me put it somewhere here. Well, c is equal to 2 minus 1 because this is 2. When you take 1 to the other side, you have this, which of course means your c is equal to 1. Oh, I've gotten c also. So I can move ahead to hydrogen now. For this hydrogen, what's b? B is 1 plus I've gotten c. C is 1. So I write 2 into c, which is 2 into 1 is equal to what's d? We've gotten d to be 1. D to be 1. So I put 1 here plus 3e. Oh, I'm going to find e now. This is 1 plus 2. This gives me 3 is equal to 1 plus 3e. If I bring 1 to this side, I would have 3 minus 1 is equal to 3e. Okay, don't let me even solve it that way. Let me do it this way. Okay, it doesn't matter. 3 minus 1 is 3e, which shows that 2 is equal to what? 3e is 3e. So what's our e from there? Our e is 2 over 3. We've gotten e. So I'm set to get a. From this side now, since my e is 2 over 3, that means a is going to be 3 plus 2 over 3. Let's find the LCM there. That's 3. This will give us 9 plus 2. You know, this 3 over 1. 1 goes times 3. That's 9. Then that you have 2. 11 over 3. 11 over 3. So I've gotten all the letters. So let us write all the letters out. What's A? A is 11 over 3. What about B? B is 1. What of C? C is 1. What about D? Or did we get E? We got E. What about D? D is 1. What about E? E is 2 over 3. Okay, I want to eliminate the denominators. The LCM of the denominator is what? What's the LCM of the denominator? It's going to be 3. 3. 3. The LCM is 3. Multiply all the values by 3 so that you can have whole numbers. 3 into 11 over 3. Then for B, 3 into 1. For C, 3 into 1 also. For D, 3 into 1. And for E, 3 into 2 over 3. This cancels this. This can sorry, this doesn't cancel anything. It's just 3 times 1, which is 3. 3 times 1, 3. This also cancels this. Okay, results. A is equal to 11. B is equal to 3. C is equal to 3. D is equal to 3. And E is equal to 2. Okay, let me put those values now. A is for P here, so I'm going to put 11 there. B is here. C is here. And C is 3. You can see it. D is 3 also. And E is 2. The equation is now balanced. And let us perform a check to see whether the equation is actually balanced or not. Let us start with phosphorus. There are 11 atoms of phosphorus on the reactant side. On the product side, we have 3 times 3 for phosphorus, that's 9. 9 plus, we have 2 here, 9 plus 2, 11. So, it's balanced for phosphorus. What about Na? There are 3 atoms of sodium here, and there are 3 atoms of sodium here. Balanced for sodium also. What about oxygen? 3 atoms of oxygen here, 3 atoms of oxygen here added together, that gives you 6 atoms of oxygen. Let's see on this side, 3 times 2 for oxygen, that's 6. Balanced for oxygen. What about hydrogen? 3 atoms of hydrogen, then 6 atoms of hydrogen, making 9. So let's see hydrogen here, 3 atoms of hydrogen here, 2 times 3 making 6, 6 plus 3 9 atoms. So the equation is completely and correctly balanced.